And remember, when the class is over, I send the video, but we lost that part. Sorry. Because I forgot on the mathematical part, sometimes I forgot. The last operation is, look, it's complicated. Is bracket, parenthesis, 4 plus 2i, close the parenthesis, minus, parenthesis again, 6 minus 4i, close the parenthesis, close the bracket, division, parenthesis, 2 plus 3i. Okay, look like horrible, however, no, it's easy because you apply the order of operations. So we can compute the top part first, or the bottom part, doesn't matter. The top part, you compute that part, and the bottom part after. Okay, so the top part, you separate mentally. You copy 4 plus 2i minus 6 minus 4i. Okay, remove the parenthesis. 4 plus 2i minus 6 plus 4i. Because this minus affects everything inside the second complex number. When you combine like term, this is negative 2. And this is 6, positive 6i. And you replace minus 2 plus 6i divided by 2 plus 3i. Now we are doing the classical problem of the division. And remember, I repeat again the process. You copy that, minus 2 plus 6i divided by 2 plus 3i. Entonces, the procedure for doing the division is always the same, systematic. You create the smart one can help me to simplification that part. And this smart one is formed by the conjugate of the complex number in the denominator, que es 2 minus 3i. And you divide one thing by itself. It's so big, this is 1 and doesn't affect my final answer. But we are doing the multiplication. This and this. I want to apply the shortcut. Que I know que es 4, 2 times 2, sorry, que 4. Plus, remember the shortcut, you want I do it step by step. 3 times 3 que es 9. Entonces 13. Okay, super. Now in the top, no. In the top, you need to apply FOIL. And this case is special. FOIL. Because they are family. Entonces you multiply this and this is negative 4. This and this is positive 6i. This and this is 12i, and this are minus 18i squared. One more time happen, que I squared is negative 1. Replace this, so we have negative 4 plus 6i plus 12i plus 18. Because double negative, no? Negative here together become positive. Ready to combine later. This and this is negative 4 and positive 18 is a real part. This is 14 positive. This and this is 18. 18i. Divided by 13. And leave it like that. Well, yeah, you can, but no. Much better express the complex number always in standard. The standard form is you separate real part, okay, you split this common denominator 14 over 13 plus 18 over 13i. And this is the beautiful final answer. Any question? Any question? Okay, entonces I promise que in the review packet I send in your corresponding moment, we are doing more operation with the complex number because it's important in the test. Okay. Okay. Everything is okay so far. Okay. Again, you change the background. I told you I told you that you don't change the background. This is the forest. I don't want to teach inside the forest. Guy, this is the second time I say. The third time is disrespectful. I consider it. So no, stop the background. Don't touch the background. Okay, I want to teach in Varadero Beach. Pero no, I am teaching in my office, right? Don't change the background anymore. I can detect who is that. Pero it's okay, it's okay. It's the second time. I warn you. Okay, guys, let's change a little bit the flavor. Let's move on to another topic inside the chapter 1, que is the quadratic equation. Wow, easy. Quadratic equation. Quadratic equation. Okay, I know that you know, but I recall the different way to solve the quadratic equation depending the example. Quadratic equation, quadratic equation, quadratic equation. Quadratic equation is equation like that. Look. A x squared plus b x plus c equal to 0. Where a, comma b, comma c, que is the coefficients z are, is the professor going to come in? Yes. A, B, and C are real number in general. Important information is that A never is 0, no 0. Because see, A is 0, look, this is no quadratic equation. So the behavior of this quadratic equation is given by the first leading coefficient, que is A. And this form, let me enclose in the box because it's important, is standard. Standard form. Entonces, my recommendation is when you need to solve in quadratic equation, you have to express it in standard. The majority of the case, we have no standard. We have completely disorganized equation, and you expressing standard. Please putting off any microphone, please, off microphone. Eso, bueno, thank you. No. Okay. Okay, there are many ways, depending on the problem. So you need to detect things, you solving using one method or using another method. The first method that we study is called it using square root method. So using a square root. And a square root is useful method. When I send the link in the email, he make another call. Okay, is when the B is 0. This I highly recommend when the B is missing, that part is missing. However, let's see. Suppose example 1. Example 1 is x squared minus 4 equal to 0. It's a quadratic equation. Yes or no? Of course, it's a quadratic equation, professor, because the degree of this polynomial is equal to, because it's the higher exponent, no? Entonces, the higher exponent is 2, this is quadratic equation. Entonces, now es obvio que in this example, A is 1, B is 0, because it's missing the linear part, and C is negative 4. But it's not important. It's not important. You detecting that B is 0, so the best selection is using square root method. And you manipulate similar to the linear equation. Similar. You isolate x squared, you move forward to the other side, apply square root, both sides. This is the reason that the name is called square root. And you know the square power and square root is under each other. It's just x. And we have a square root for x 2. But you need to don't forget double sign, plus and minus. So we have two solutions. The solution set is 2 and negative 2. Positive 2 and negative 2. Oh, leave it like that. It's okay. So see you in the test leave like that, this is perfect. Because everyone understands this sign get double sign. Two solutions. Okay, to say it's easy, you manipulate similar to the linear equation. You apply a square root. A square root allow me convert x squared to just x, but don't forget double sign plus and minus. Okay, now we have another example here. Okay, similar. So you x squared, you move 9 to the other side like a minus 9, and you apply square root. Therefore, x is equal to the square root negative number. I know que es imaginary, it's 3i and plus or minus. So actually, the solution contains two solutions, and both solutions are imaginary. 3i positive and minus 3i. It doesn't matter the order here. There's two solutions. You put in either order or like that. The way you prefer. It's the same. Everyone follow me? Square root.
Where did you get the I?
Say again?
How did you get the I?
The I was, Mr. in the first class, I explained square root negative 9 is I times square root positive 9. And square root positive 9 is 3i. So when you see a quantity negative inside the square root, the answer that we expect is imaginary, not real. Okay, watching the video for the last class. Clear or confusing? Come on.
Yeah.
Okay. Example 3 of the square roots. Suppose that we have this example. X plus 9 is squared plus 16 equal to 0. Well, there are many ways to do this. You can expand, you can use it another way, but no, I take advantage. Okay, we have somebody do the factorization this part. So this is similar to this, case a square. Look, so you isolate this term. So it's x plus 9 square equal to, so you move 16 to the right hand side and you apply square root. One more time, square power and square root is cancelled out and stay alive, only x plus 9 and square root negative 16 again is the same situation as imaginary is 4i. And don't forget plus or minus. This is the thing I need to warning you. Plus or minus. When you apply the square root, don't forget plus or minus, always, anytime. So what the final answer? Well, the final answer is you solve for x. I move 9 to the other side like a minus 9 plus or minus 4x. And this is the answer. Okay, you write like that if you want. Solution set. There's two solutions. So normally the quadratic equation contains two solutions. The first solution expressed like a complex number is minus 9 plus 4i. Separate by comma. Minus 9 minus 4i. Okay. Separate by comma. Any question? Example 4 now. Okay, example 4 is easy. Is p plus 10 squared is equal to 100. Is a quadratic equation? Of course, it's a quadratic equation. When you see degree 2, it's a quadratic equation. It's ready to apply square root? Of course, it's ready to apply square root, both sides. Square and square root cancel, stay b plus 10 only. And the square root 200, you know, 200 is 2 times 100. And the square root 200 is square root 2 and square root 100. And the square root 100, I know get 10. The answer is 10 radical 2. Okay, and don't forget plus and minus. Finally, B, is our variable is minus 10 plus or minus 10 radical 2. In this case, leave it like that. We have no complex. So this is a complex number. However, this is not complex. It's a real number. But the difference is that this is irrational solution. Irrational solution. But it's okay. It's real. So if you see number that don't contain I, it's a real. It's a weird. It's a, okay, I understand it's weird. It's irrational. Irrational is, you know, radical 3, radical 2. Another example, pi is irrational number. Que have infinite decimal place. But it's okay. Okay, this is the square root. And this is the only way, no. And you need to know everything because in the test I specification. I want you solving using a square root. Or you want guys solving by another method and another method I want to explain now. Everyone follow me? Follow me, follow me, follow me. Soraya, you follow me? Okay, good, Mira, good. Karina, say something wrong, guy. Ulises, Haile, Daniel, don't worry for attendance because Skype record your name in the background. So when the class is over, I can see your name. The student is present now. Okay, let me now to explain another way to solving the quadratic equation, que is called by complete square. The square method. Okay, let me try to explain what means complete square and how we using this idea to solve the quadratic equation. Let me try to explain complete square. Completed the square. For example, there are trinomial like that x squared plus 4x plus 2 plus 4. And when you factorization this trinomial, the answer is in this case 2, no? Because 2 times 2 is 4, and 2 plus 2 is 4. It's a coincidence, and the sign is plus plus. And when this situation happens, when they are twin brothers, this is x plus 2 squared. Entonces, this trinomial que satisfies this idea is called perfect square trinomial. Another example to understand this. X squared minus 10x plus 25. Well, the factorization is xx 5 because 5 times 5 is 25 and 5 plus 5 is 10. In this case, the sign is negative. So the idea of the sign depends on this sign. Because this sign, I suppose, always gets positive. Si es negative, no, it's not perfect square. So the answer is x minus 5. The majority of the trinomials do not satisfy this, but I try to enforce the situation to become like a perfect square. And this process called complete square. Let's see example. I have 1, 2, 3 examples. Very, very interesting. Example 1 of the complete square is super easy. Look at that. We have this equation, x squared plus 4x plus 10 equal to 0. Entonces, I say you solving this equation using completed square. By the way, I know that the majority of the students don't like completed square. However, in the test, one question is mandatory doing using completed square. So I specification. I specify okay, this question is you solve it by completed square. So you solve it another way, you have 0 credit. So it's completed square, one question in the test. Okay, so what is the organization that I propose to you? Easy, look. You copy this. You copy this. You move 10 to the right hand side. And you complete the square. What is the, well, in this case, I saw, look at this example, 4 is the number that we need to complete the square. Okay, but in this is a coincidence of the example 1 here. But in general, what is the formula? To find the number that complete the square. Well, the formula is easy, it's b over 2 square. B in our example f4, look, this is a, this is b, this is b, b is 4. Now 4 divided by 2 square. 4 divided by 2 is 2, and 2 squared 4. And this answer is exactly this number. Okay, in this case, it's a coincidence, but not always happen. So now, when you complete the square, it's obvious that the factorization of this trinomial is x plus 2 squared. Exactly like that. Look at that. And on the right hand side, we have minus 6 because negative 10 plus 4 is negative. Now ready to apply a square root method. So a square root method is a continuation of this. X plus 2, and this is a plus and minus. Don't forget radical 6. Unfortunately, you cannot simplification anymore, but you put I because it's negative, radical 6. Finally, x is equal minus 2 plus or minus I radical 6. And this is my final answer. Okay, don't frustrate. Little by little, you understand complete square. Complete square, this is the magic formula. Magic number that complete the square. That formula. You found using that formula. Okay, let's do it one more example. That was example 1. Now example 2 of the complete square. No big deal. No big deal so far. Okay, suppose x squared plus 6x plus 18 equal to 0. Ooh, I say that is solving this quadratic equation by completing the square. Okay, let's do it. Let's say you copy x squared, you copy 6x, you copy something, one number can complete the square, you put a box, and 18 I move to the right hand side. In order to doesn't affect, you introduce artificially one number in the left hand side. You introduce the same number in the right hand side in order to keep the equilibrium of the equation and doesn't affect our original problem, no? So what is the magic number? Well, the magic number is b over 2, so b is 6. 6 divided by 2 squared. b divided by 2 is 3. And 3 squared is 9. So the magic number is 9. 9 here and 9 here. When you factorization, this trinomial is x plus 3 squared. Where come from this x? This is square root this. Where come from this 3? This is square root this. And the right hand side we have minus 9. Okay, it's subtraction this. Now ready to apply square root both sides. X plus 3 alone is equal plus or minus. Don't forget plus or minus because you apply square root method. 3i. Square root 9 is 3, and this is negative inside the square root. It's obvious it's imaginary. Therefore, finally, is you isolate the x. X is equal minus 3 plus or minus 3i. End the story. Final answer. Any question? Any question? Any question? No, it's easy. All right, let me say opinion. It's easy. Professor would deny be negative. Well, the reason is because, let me see, because I subtracting means negative 18 plus 9, no? You subtracting is 9, no? Pero you put the sign of the bigger number that is 18. That is the reason it's negative. Because you combine negative 18 and positive 9. Got it? Sure? Okay, let me complicate a little bit. Just a little bit, not too much. The most complicated case Example 3 is when the coefficients in front, so when the A is not 1. So the problem we are doing so far is easy because A is 1, look, A is 1. Here, the coefficients here is 1. And example 1 is also 1, look, 1 here. But let's see what happens when the A is not 1. It's not too easy. It's not too easy. It's not too easy. Is suppose this equation 2x squared plus 5x minus 3 equal to 0. So what is the organization? Well, it's similar. The organization is similar. You move, so you copy down, bring down this, move 3 to the other side, positive, and you copy something here. Pero bueno, before this, no. Before this, you divide by 2. Why you divide by 2? Because I need to enforce the situation in which the coefficients, the leading coefficients in x squared should be 1. So x squared plus 5 over 2x equal 3/2. Okay, now the problem is similar to the problem we were doing before. So you divide by 2. In another example, you don't divide by nothing because A is 1. When A is 1, you don't need to divide, but when the A is different to the 1, yes, you need to divide. So my B value is 5 over 2 now. And the formula that the professor explained was you divide by 2. When you divide by 2 is 5 over 4, no? And a square. And a square, this is 25 over 16. And this is the magic number that I put inside this box. 25 over 16. 25 over 16. Okay, now, bueno, I know that when you are doing this, I guarantee you 100% that this trinomial is perfect square. And the factorization is too easy. The factorization is x, que is the square root of this guy, and the square root of this guy is 5 over 4. Square root 25, so square root 25 over 16 is equivalent to 6, square root 25, square root 16, this is 5 over 4. And this sign is plus. Well, because actually both are positive, but the important sign is this. So this sign you copy and paste here, and square. And the right-hand side, when we combine the fraction, the least common denominator is 16. 16 divided by 2 is 8 times 3 is 24. Plus, this is the same, 25. And we combine 49 over 16. Okay, I suppose can you remember very well addition, subtraction, fraction, no? Doesn't care, I don't care, because you use a calculator if you want. Now ready to apply square root. So let me copy again. X plus 5 over 4 squared is equal to 49 over 16. Ready to apply square root. It says x plus 5 over 4 without a square and a square root. Here in the right hand side you have plus and minus. Please don't forget square root 49 over square root 16. This is 7 and this is 4. This is 7 over 4. Okay. Almost we finish. So now finally ux is equal, I move, and here no necesary paréntesis. Entonces if you move 5 over 4 to the other side, you have minus 5 over 4 plus or minus 7 over 4. Okay, entonces my recommendation is now separate in two pieces. Negative 5 over 4 plus 7 over 4 and negative 5 over 4 minus 7 over 4. So you decompose this double sign plus and minus in 2 in order to understand much better, no? In this case, it's easy because the denominator is the same, it's 4. And minus 5 plus 7 is 2, positive 2, it's 1/2. And it's my first answer. The second is 4 is minus 12, is negative 3, is my second answer. Therefore, the solution set for this equation is half positive and -3. Two solutions. Okay, so the new thing that brings me this example is when the A is no 1, you divide by this and you create artificially the A1. Okay, after that, well, the procedure is similar. So you find the magic number. Sometimes it's a little bit more complicated because it involves fraction, but it's okay. Magic number. And the rest is similar. Square root in the last page, the last part. And don't forget, please, plus and minus. Do you see that? How do you feel? How do you feel in this last example? Complicated or easy? Entonces now, to some students, I understand. Say, no, professor, I don't like this. Yeah, I understand, because it's a little bit long. And there are another way to do this easier, que es the quadratic formula. Okay, I want to derive now, but using the same idea. But keep in mind que in the test, at least one question is mandatory doing by completed square. Okay, I suppose it's not hard in the test. Okay, let me try to present to you solving by quadratic formula. Okay, solving quadratic equation by quadratic formula. Yeah, I want to derive the quadratic formula because I want you don't forget the quadratic formula. It's important. Suppose that we have this equation. Okay, by the way, this is standard form. In the real life, not always, we have the elegant. So you recognize the standard because right hand side must be 0. Number 1, and number 2, you organize the equation in descending order of the degree. Degree 2, degree 1, degree 0. Degree 0 is missing the x, and degree 1 is also missing. So suppose I want, okay, I don't remember the quadratic formula. Yeah, I try to solve it by completed square. So you copy ax squared plus bx equal minus c. I move c to the other side. Now you divide by a. Similar. You divide by a here, you divide by a here, and you divide by a here. So when you divide by a, you convert this like a 1, it's exactly what we need, plus b over a x. Now the magic number here, I have no idea, and we have negative c over a. Okay, super. Now what is the magic number? Well, the magic number is you take b, okay, b actually, no b, is b over a divided by 2, so you put it 2 in the denominator, that is the risk-based division, and square. Actually, it's b squared over 4a squared. This is my magic number, okay, introduced here artificially. Okay, when you are doing this action, I know very, very well that this trinomial is perfect square, and the factorization is x plus something. X plus the square root of this guy get b over 2a. A squared. And the right hand side, well, you put together, this is 4a squared, is the least common denominator. So we have b squared, get this guy, look, positive, minus 4ac. Because 4a divided by a, 4a times c is 4ac is negative. Okay, ready to apply square root both sides. You apply square root both sides. I know que square root and square cancel out. I know que the answer is plus or minus, and this is square root b squared minus 4ac divided by square root this guy gets 2a. Finally, x alone, you isolate is minus b over 2a plus or minus square root b squared minus 4ac divided by 2a. In this case, it's not coincidence, it's a fact that the denominator is the same, it's 2a, and you can write in a more elegant way this quadratic equation. Okay, beautiful. Quadratic equation. It's an amazing tool. It helped me to solving quadratic formula. Quadratic equation, sorry. Using the quadratic formula. Entonces I saw some students that don't remember very well. You don't worry because the test is at home, no? And you have your notebook and you see it in your notebook. Pero when the class is face-to-face, some students make a mistake doing this because I saw that some students write like that. Minus b plus or minus square root b squared minus 4ac divided by 2, only that part. This is wrong. Okay, divided by 2, everything. I proved this, right? Now ready. We are ready for solving 1, 2, 3, 4, and 5 example I bring now. Okay, we have time. Example. Okay, you don't need to know the derivation for the formula. Only memorize the formula and you see. That's it. Okay, let's do example 1 of the quadratic equation solving by quadratic formula. Example 1. Example 1 is x squared plus x plus 5 equal to 0. Entonces, the first thing is to make sure that my equation is expressed in standard. Of course, it's expressed in standard. This is step 1. Step 2 is determine who is ABC. It's obvious that A is 1, B is 1, and C is 5. And the rest is just plugging in into the quadratic formula. I copy again my quadratic formula. Only replace. Who is B? Oh no, B is 1 and minus 1 plus or minus the square root 1 squared minus 4 times 1 que A is 1 times C que is 5 divided by 2 times 1. Okay, I like that way, guys. Just replace. Don't do any arithmetic operation because you're doing some arithmetic operation. Maybe you make a mistake. No, it's a moment to make operation. So now I focus in the operation inside the radical. Okay, the rest I don't touch for a moment. So this is 1 squared que 1 minus 4 times 1 que 4 times 5 is 20. And you're subtracting negative 19. And you compute the square root negative 19. Okay, by the way, it's I, no? I square root positive 19. Because 19 is a prime number, we can know simplification more. However, it's I because remember, square root negative number is I. Okay. Now I write that down. Negative 1 plus or minus I radical 19 divided by 2. Because 2 times 1 is 2. And leave it like that? No, because it's a complex solution. When it's complex solution, you put in a standard form in which you separate the real part as negative 1/2. Look, you split this common denominator here and here. And here, the imaginary part. There's a plus and minus because we have two answers. I radical 19 over 2. Boom. Final answer. Some people say, well, professor, I can write in that way. Negative 1/2 plus or minus radical 19 over 2i. Yes, you can. Doesn't matter the way. You put I in the front or you put I in the last. Doesn't matter. Any question, guy? Quadratic equation. Any. Super. Okay, I told you this chapter. This chapter is easy. In the college algebra, the first chapter is a piece of cake. The second, no. But the first, yes. Okay. Another example. Example 2. Okay, this is easy also. X squared plus x plus 1 equals 0. Okay, it's already expressed in standard. Good. Second step is determine who is A, B, C. In this case, a coincidence, everything is 1. 1, 1, 1. Okay, I copy my formula again because I don't want to make a mistake. Only I have my formula. I substitution, plugging in the corresponding value, minus 1, plus and minus square root, b is 1 square minus 4 times 1 times 1. Everything is 1 in this example, 2 times 1. Yeah, I focus it in the operation inside the square root. I make a zoom. I put a blue color because this is the order of operation you respect. 1 square is obviously 1. Wait a second. 1 square is obviously 1. Minus 4 times 1 times 1 is 4. Minus 3. And square root negative 3. Oh, it's imaginary again. It's I radical 3. Remember, 3 is a prime number and leave it like that. So the answer is so far negative 1 plus or minus I radical 3 over 2. Okay, this 2 you put here and you put it here. You split the denominator in order to represent the complex number in standard form. That is my beautiful final answer. How do you see example 2? Was easy or no? Easy or no? Okay. No opinion? Easy or no? Yeah. Okay. 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 Let's do example 3. Example 3, we have x squared plus 3x minus 5 equal to 0. Okay, again, it's already expressing standard. Nice. You determine who is A, who is B, and who is C. A is 1, B is 3 positive, and C is negative 5. Okay. I copy again my quadratic equation. Minus b plus or minus square root b squared minus 4ac divided by 2a, and substitution. Be careful, little by little, slow down. B is 3, is minus 3, plus or minus square root 3 squared minus 4 times a is 1 times c is negative 5. Be careful with the sign. Divide the whole thing by 2 times 1. Okay, again I focus on the operations inside the parentheses. Here, there. Okay. Now 3 squared 9. Be careful with the sign. Look, we see, wow, 2 negative. This negative and this negative. Together is positive. 20. It's 29. And the square root 29, leave it like that because 29 is a prime number. So we can know simplification more. And the answer is minus 3 plus or minus square root 29 divided by 2. In this case, not necessary separate this common denominator because this is a real solution, no imaginary. When this is imaginary, suppose que es minus 3 plus or minus I radical 29 over 2. Entonces, in this case, mandatory separate like that because I want to emphasize who is the real part and who is the imaginary. This is the real part and this is the imaginary part. But in this case, no. In this case, it's a real number and leave it like that. We have two solutions, and the solution are, look, is minus 3 plus radical 29 over 2, comma, minus 3 minus radical 29 over 2. Okay, this is one way to express the solution set. Oh, like that. You copy separate by comma, or you using this famous symbol plus and minus que represent two solutions. Okay? Okay, but I want to complicate a little bit more. Introduce a new idea. Introduce, for example, when the quadratic equation not necessarily is expressing standard, okay, you need to organization standard to start a problem. Okay, example 4 and example 5. Look, example 4, we have that equation. Suppose in the test I give you this equation. Equal negative 15x. And you say, wow, what the hell is that? It's quadratic equation. Of course, it's a quadratic equation. How do you know this quadratic equation? When the degree is 2, it's a quadratic equation. This is the clue to recognize the quadratic equation. Entonces, my next question is expressed in standard? No, of course, no. Because the professor say the standard is the right-hand side 0 and organized in descending order. You bring down this. I move 15 to the left. Positive. And this is equal to 0. And this is the standard. So we are ready now to start. Entonces ahí declaré que A es 18, B es 15, and C es 2. And we're using the quadratic formula. Why not? In my opinion, this is the powerful way for solving any quadratic equation with quadratic formula. Entonces now you try to avoid the complete square. The complete square is only using in the text when it's mandatory, no? This is the quadratic formula that we're using every day. Every day from now, guys. I promise you when the class is over in December, we're using this formula. Entonces minus b is now minus 15. Plus or minus square root. 15 squared. Minus 4 times 18 times sec 2. Divided by 2 times 18, sorry. A is 18. Okay, I like this way. You copy, the only thing replace the corresponding value in the variable and the coefficients ABC. And don't do anything. Now this is a moment, little by little, be careful. We are doing the operation inside the radical. Entonces I use my calculator, of course. This is called algebra. It's supposed you know arithmetic. You put in the calculator 15 squared. 15 squared is 225. Minus, and you multiply 4 times 18 times 2. The answer is 144. That's the operation here, 144. Now subtraction is 81. And you compute the square root 81. Because we are doing this big square root, no? That's 9. Super. Now so far we have negative 15 plus or minus 9 divided by 36. Okay, 36 is the multiplication. 18 times 2, no? Entonces I highly recommend in this moment separate this compound answer into minus 15 plus 9 over 36 and minus 15 minus 9 over 36. So this decompose this plus and minus and plus and minus. Doesn't matter the order is not important. And you're subtracting is negative 15 plus 9 is negative 6 over 36. And now always mandatory reduce the answer in lowest term. Entonces es 1, 6, negative 1 over 6, because 36 is 6 times 6, you know. He at least cancel out 1, 6 and stay alive 1, 6 in the denominator part. Now the second one is negative 24 divided by 36. When you reduce into thirds, negative 2/3, because 24 in my mind is like a 2 times 12. And 36 is 3 times 12. Or you break it down, whatever, you know. 24 is 2 and 12, 2 and 6, 2 and 3. 36 is 2, 18, 2, 9, 3, 3. You copy that. 24 is 2 times 2 times 2 times 3. Look at that. Replace. Divided by 2 times 2 times 3 times 3. Okay, now what is cancelled? What is stay alive? This is cancelled. Look, stay alive this. 2/3. Of course it's negative. So what are the answers? My answer is, okay, solution set for this quadratic equation is -1/6, -2/3. End the story. Any question? This is easy, but it's important. Extremely important. Any question, guys? We're doing one more. No question. Okay, good. We're doing one more, and that's it for today, because next time we start new thing, a little bit more complicated. Okay, let me try number 5, and that's it. Number 5 is in the last quadratic equation that we solved today. No in the subject, but today. X squared plus 1/3 x, this is plus minus 2/3 equal to 0. This is a quadratic equation. This is already expressed in standard. Nice. Right hand side is 0. Descending order of the degree 2, 1, 0. But what is the complication I introduced in this example? Fraction. So this is classical in algebra. When you want to remove the fraction, you multiply the entire equation by the LCD. In this case, the LCD is 3. Because it's the only number we have in the denominator, you multiply the entire equation by 3. Big 3 here. And 3 times this is 3x squared. And 3 1/3, it's obvious it's 1, because this 3 is cancelled. And this is -2. And 3 times 0 is 0. And we have a new equation, que es obvio que es equivalent to the original, however, do not contain fraction. So nobody, this is totally stupid, try to put fraction inside the quadratic formula. It's possible, yes, but it's too hard. No. Nobody doing it that way. You multiply the entire equation by the LCD, and it was easy because the only number in the denominator is 3, but see it's different denominator, you will find the least common denominator and multiply by the least common denominator and magically disappear the fraction. And you determine who is ABC. A is 3, B is 1, and C is -2. Plugging in where? In the quadratic formula. Okay, who is B? 1. You see that the formula contains minus here. And -1 plus or minus square root. 1 squared. -4 multiplication by 3, que say multiplication by C, que is -2. Be careful with the sign. Sometimes we have double negative. You need to be aware for that situation. 2 times 3. Okay, let's make it zoom because I want to focus, stay focused in the operation inside the rack. This is the order. Another order is wrong. We focus on this. 1 squared is 1. Minus. No minus. It's plus because we have double minus. Plus something. Plus. 4 times 3 is 12 times 2, 24. It's 25. Okay, easy. And square root 25 is 5. Okay, so far, my solution is -1 plus or minus 5 divided by 6. Where come from this 6? 2 times 3. And you separate -1 plus 5 over 6 and -1 minus 5 over 6. Okay, this is 5 minus 1, 4. Reduce the lower third, 2/3. This is negative 6, negative 5, negative 1, and negative 6 divided by positive 6 and negative 1. Therefore, the solution set for this equation is 2/3 positive and negative 1. Okay, we have time or no to do all the thing or no? What do you think? What do you think? We have time, we have 5 minutes, no? Okay, no, it's okay. Stop here. Guy, please don't